Good morning, friends. Now we are going to discuss the topic is the transportation problem in operation research. Here, transportation problems deals with the transportation of commodity, a single product from M sources. M sources which indicates as what origins, supply, capacity, factory, warehouse, where it is available, where it is manufacturing, that place to N destinations. The destination may be sink, demand, requirement places. So in these places we are going to transport the goods one place to another place. In general, the transportation problem can be expressed mathematically as minimize z equal to summation of I equal to 1 to m, summation of j equal to 1 to n, cij, xij, subject to the constraints summation of j equal to 1 to n, xij equal to ai, which indicates supply, and summation of I equal to 1 to n, xij equal to bj, which indicates a demand, total demand and total supply. Here the main objective of the transportation problem is always minimize. It is very important because in TRB, old PG TRB questions and that CSSC questions also one questions came. Here the objective of the transportation problem is what? Optimize or minimize or maximize or none of this. Here you be very careful, do remember this is a very important one. Objective of the transportation problem is always minimize, because it's a what? Expenses. Whenever the expenses is minimized, the company will get more benefit. That's the reason objective of the transportation problem is always minimize. Do remember this is a very important point. In all the pages I underlined the important one. So do remember that objective is always minimize. Now the second one is the important points to remember in TP. Here I given 5 notes. These 5 notes are very important. From the 5 note you can see one question in old question paper in where TRB and also CSSC, in all the competitive questions you can see one question from this 5 note. So it's very important. I'll give that suitable examples also. I will explain the same by example. Here the first one is what the necessary and sufficient condition for a transportation problem to have a feasible solution is summation of ai equal to summation of bj, which indicates the what? Balance. That meaning is demand is equal to supply. So your demand is equal to supply. If it is satisfies this condition only, you can say the given problem is balance. When it is comes balance only, you can get a feasible solution in the transportation problem. The question will come in the objective type when the transportation problem will be what? Feasible. The time you are going to write the condition is demand equal to supply. When it is satisfying this condition only, it is also called balanced condition. If the transportation problem is a balanced condition only, you will get a feasible solution. That is very important. When the problem will get feasible, solution, if it is satisfies the rim condition, or you can say it is satisfies the condition of balance, if it is the demand equal to supply, if it is comes like this only, the problem of the transportation will get feasible solution. The second one is if demand is not equal to supply. If demand is not equal to supply, the problem is what? Unbalanced transportation problem. Sir, how to solve the unbalanced transportation problem, sir? If any unbalanced transportation problems comes, first you are going to convert the unbalanced transportation problem into balance by introducing that dummy cost. That I'll give one suitable example later on. First I will explain the note which is important for the examinations cases. So now third one, for any transportation problem, the coefficient of all xij in the constraints are unity. This is also the previous questions. Xij constraints are 0 or -1 or infinity or none of this or 1. If it is given like this, you are going to select that. You are very clear. This is very important. The constraints should have what? Coefficients of xij must be in the constraints or unity. And the fourth important one, the number of variables in m cross n. What is m? What is n? M, which indicates number of rows, n indicates number of columns. So now the number of basic variables in an m cross n balanced transportation problem, it is very important. If it is a balanced only, you can find the basic or non-basic everything. So now the number of basic variable in an m cross n balanced transportation is at most m plus n minus 1. And the fifth one is the number of non-basic variables in an m cross n balanced transportation is at least. When it is at least, non-basic variables means it comes at least m into n minus m plus n minus 1. When it is a basic variable, the balanced transportation is at most m plus n minus 1. Now I'll explain all the 5 note by simple example. Now when you are going to get the feasible, when it is feasible means demand must be equal to supply. Here the given problem, I taken one simple example to explain this. Here the demand equal to supply. Here what is the demand in this? 10 plus 10 plus 1. Here it is what? 30. Supply, you are adding all the supply value, which comes also what? 30. Here demand equal to supply. Therefore this is called balanced transportation problem, and this is also called what? The problem which get feasible solution. If it satisfies this condition only, you can say it is what? Feasible solution. And also the other name is called this is called balanced transportation problem. It is very important. This is called sufficient, this is called necessary and sufficient condition. This is also what? Necessary and sufficient condition means the balance. You be very careful before solving the problem. You check this condition first. This is the first very important condition in the transportation problem. And the second one, it says what? Unbalanced. The second one is what? Unbalanced. Unbalanced is very clear. It is equal. Suppose instead of here the 9 is given, here it is a problem is that 10 is given, is very clear. Okay. Suppose in the place of comes here sir 7, 12, and in the place of 11, suppose if it is given 10, this total will come what? 29. Here this is what? 30. So now here the unbalanced cases comes. Unbalanced is what? Here 29, it is what? 30. Here unbalanced TP, demand is not equal to supply. The example sum is what? 30, here is a 29. If it is comes, you can say it is what? Unbalanced transportation problem. Now for any transportation problem, the coefficients of all xij in the constraints are unity. This note number 3 and note number 4 and note number 5, these 3 notes I will explain after solving the transportation problem. Okay, now we'll the transportation problem. The transportation problem, the TP, can be classified into 4 models. That first one is balanced transportation problem, and another one is unbalanced transportation, balanced TP, unbalanced TP, and the third one is maximization. This is a special case, maximization of what? TP. And last one is degeneracy TP. Here always I told you very clearly, the TP transportation problem whose objective always what? Minimize. This is very important. So that's the reason the third one is a special case of maximization. Maximization is a special case in TP. Now one is the balance is what? Demand equal to supply. Unbalanced, demand is not equal to supply. So maximization TP. So in the problem itself, the question itself, they will give the word maximization. Whenever that maximization comes, they will not maximize the expenses. They will maximize the profit. So that the question of maximization, the special case, always you can see one word in the question itself. Maximize the profit. Solve the transportation problem and maximize the profit. So what is a degeneracy, sir? Degeneracy. So first I will explain the non-degeneracy condition, then I will go to the what? Degeneracy. So non-degeneracy condition. What is non-degeneracy? This is also another one important to multiple choice question. Non-degeneracy condition in TP. So what is non-degeneracy condition, sir? M plus n minus 1 equal to number of allocations. If it satisfies this condition only, you can say that the given TP is non-degeneracy TP, non-degeneracy condition in TP. So degeneracy means m plus n minus 1 is not equal to number of allocation. If it is not equal, you can say it's a degeneracy TP. When it is equal, you can say it is a non-degeneracy TP. Sir, I am not getting this. What is the m plus n minus 1 equal to number of allocations, sir? So I will explain one through this one example, this case. Now, when you are going to solve the transportation problem, we have two stages. That is called stage 1 and stage 2. Here, stage 1, you are going to find that initial basic feasible solution, IBFS. That stage 2, you are finding optimal solution. Optimal solution. So initial basic feasible solution of any TP, you can find the three methods, the main three methods, the IBFS. You can find by using this three method. The name of the method is called NWCR, that is North West Corner Rule. The first letter of each word, NWCR, and second one is LCM, least cost method. Again, the first word of each letter. The third one is WAM, Vogel's approximation method. Vogel's approximation method. So now, whenever you are going to solve the TP, we have to analyze in that two stages. The stage 1 is finding a what? Initial. It is not a final solution. Just finding an initial basic feasible solution that you can find any one of the three methods. You don't need to use all the three methods to find the IBFS. If any TP is given, you can use any one among these three. But you may have the doubt. It is also another important questions in the previous question paper. So now, among the three methods, which is the best one? Which is the best method? Which gives that best result among the three? So now here, WAM is the WAM, Vogel's approximation method, gives always close to the optimum solution, or it is it gives the very least value, because in transportation is objective is always what? Minimum value. Now the WAM, which gives always minimum value, compare with the another two methods. Here NWCR, LCM, WAM, which is the best. The question comes, which gives the least value among the three, means you have to take the what? WAM. Okay, well, this is a very important one. And another one question also I want to tell you in that old question paper. To find out the IBFS of TP, the option is given to find the which method is not applicable. The question is, the previous question I am telling, which method is not applicable to find the IBFS of TP. Here the option is given NWCR, LCM, WAM, and the fourth one they given is Hungarian method. Here this 3 is helpful to find the IBFS. Hungarian method is to finding a what? Assignment algorithm only what? Hungarian. So that Hungarian is the option. So that's the reason you have to be very careful in this. You remember this 3. To find the IBFS, we have the names what? NWCR, LCM and WAM. And among the 3, which is the best? Best means the least, which gives the least value. So WAM. So you remember the WAM. WAM is called Vogel's approximation method. I want to tell you one more thing. The name of the another name of the WAM is, you can call the another name is penalty method. Another name of Vogel's is called penalty method. Vogel's approximation method, or you can call it as what? Penalty method. So now I will recall this the same once more again. The TP is always what? Minimization purpose. The balance is demand equal to supply. Unbalanced, demand is not equal to supply. The special cases maximization, that comes along with always what? Maximize the profit. Degeneracy, here m plus n minus 1 not equal to number of allocation. Here non-degeneracy means m plus n minus 1 equal to number of allocation. So when you are going to solve the TP, I told you we have 2 stages. First stage 1 is for finding a IBFS only. It is called what? Initial basic feasible solution. So that stage 2 only finding a optimal solution. Now when you are going to discuss that the objective type questions and all, you don't need to bother about the optimal cases. Optimal is only the big questions part. Here the small questions will mainly concentrate on only these 3 methods, and for the cases of only the IBFS. So here the 3 methods we have is NWCR, LCM, WAM, or another name of the WAM is penalty method. Okay. Now I will explain this 3 by one example. But one more thing here, all the 3 will give, you may have another one doubt. Sir, if I am going to solve one problem by the 3 methods, the 3 methods will give the same. No, this 3 method will give the 3 different answers. So I will take one problem, I will explain the same one problem by 3 methods. Then only you will come to know that which is the best among this. By seeing the result, you will understand which is the best among these 3. Now I will explain one problem by first I will explain north-west corner rule. I am taking only one example to explain the 3 method. Then only you will come to know that the different answers, and also from the answers you will come to know which is the best also. First I will take it north-west corner rule. NWCR, north-west corner rule. So I told you, whenever you are going to solve that the TP, first you are going to check the condition is the given problem is balanced or not. If the given, if it is satisfying the balanced condition only, you will get a feasible solution of a given TP. So now here the total value of the demand is comes what? 30, and the supply values also comes what? Therefore this problem is satisfying the condition of what? Balanced. Demand is not equal to supply. It's very clear. Therefore which gives the what? Feasible solution. Now north-west corner rule. What is the north? Here if you are coming from this, it is what? North. You are coming from north to west by selecting a corner cell. Rule means corner cell. Now here this is a data what? Supply. Here this is a given what? Demand. Destinations. This indicates a destination D1, D2, D3, which indicates factories or supply sources. Anyone you can put warehouse. From the warehouses you are going to take the what? Goods. Here what is there inside that? This cell values which indicates cost. If you want to supply the goods from factory 1 to destination 1, you have to spend minimum of 1 rupee. 1 rupee means if you are supplying amount of goods into 1 rupee. Suppose you are supplying 5 kgs or 5 ton, you are going to multiply with the cost. Okay, this indicates what? Cell cost. This cost fixed. Okay, you can't change that. So now first I will explain what is a north-west corner rule. You are coming from north to west by selecting a corner cells. If you are coming from north, from north to west, which is the first corner to you, here 1. Now after selecting the cell, you have to see first bottom, demand, how much you want. Here this says what? 10. The destination 1, and you are selecting the first corner to you from the north. North means this is, you are coming from what? North to west. So now here north means you are going to consider the first corner to you. If it is coming corner means 1, this is the first cell is a corner. After selecting, you have to see the demand first. So demand is what? For this cell demand is 10. Now you are seeing the corresponding factory only. So here demand is 10, but the corresponding factory supply, the availability is what? 7. Your demand is 10, you are comparing these two values. Your demand is 10, but availability of that company level is what? 7. Therefore you are taking only 7 from the good one. You've taken 7, but still your demand is there. So that's why the balance will come what? 3. Now which one comes fully empty? Here the factory level is empty or destination level is empty. That which one comes empty, that part you are going to remove from the problem. So if we are going to compare this, here the factory one is what? Fully empty. That's the reason you are going to remove the factory from this. Just you are going to put a cross line that indicates that portion is removed. So due to the next calculation, you are going to consider only the 6 remaining cells. Don't consider this. Again you are coming from the north to west. You are coming from the north means you are going to consider that corner cell to you. If you are coming corner, which is coming corner to you, here this is the corner, because this portion is removed. When you are going to put a cross line, that indicates what? That part is removed. If you are coming corner to you, again the corner will come what? 0. Now first you are going to see that destination demand, then you are going to check the corresponding factory available level of the factory. You need only 3 units, but here in this available place is what? 12. What you need, you see that, compare that, you need 3, but available is what? 12. You need only 3. That's the reason you taken only 3, you keep the remaining the grown itself. You taken 3, just you supply in this place. This is a corner to you in the left. Now so which one we have to remove? We have to remove the factory or the destination. I told you very clearly which part is fully completed, which is getting cancelled. That portion is you are going to remove from the problem. Here the destination, the demand is completely over. So you are going to remove the destination part. Now you are going to consider remaining 4 cells only to do the calculation. I mean the next stage. If you are coming here, that the left corner to you from the north, which is coming corner to you, again left, which is what? 4 is a coming corner to you. So you are considering this cell. After selecting this cell, you have to check. You check first whose demand is what. Always see the demand. Then only you go to the factory. So here your demand is 10. The corresponding factory availability is what? 9 only. That's the reason you taken the 9 from the factory. Still your demand comes what? 1. You've taken 9 from the factory. That's the reason you supplied only the 9 unit to the what? 4. Again you compare this. Factory level is over or destination level is over? The factory level is over. That's the reason you remove the factory 2 from the problem. Now you do the calculation with the remaining cells of what? This 1 and 5. So again you come to the corner from the north. So now if we are going to consider that 1 comes corner to you. So after selecting these cells, you check the bottom of the demand, whose demand is 1. Then corresponding availability level is what? 11. You need only 1. That's the reason you've taken only 1 from the factory. You keep the remaining there itself. You've taken only 1 unit from the factory, you supply here. You check which is fully over. Either destination part is over or factory level is over. Here the destination part is fully over. You remove the destination from the problem. The last only 1 cell exists. That is what? 5. You see the demand is what? 10. That available level is also what? 10. Then you taken that 10, you supply here. Both will get cancelled. When it comes like this, if it is satisfying the condition of the balanced only, the problem will end like this. Then only you will get feasible solution. So everything getting cancelled. Demand is entirely over and supply is also entirely over. Nothing is remaining here. After supplying like this, now to find the IBFS, B, F, S. Just you are going to multiply. You supplied 7 units. Actually, you have to spend 1 rupee here. 1 into 7. That 1 indicates cost of the place. Here, then where you supplied again? The second row, the first one. 0 into 3. The third one is 4 into 9. Then 1 into 1. 5 into 10. 7. 0. 36. 1 plus 50. Add all the values. 50 plus 36, 86, 87 and 7. 94. So you are going to spend, you have to spend minimum of 94 rupees to supply the goods by using the northwest corner rule from the demand destination to the, from the factory to the destination's place. Now see here, IBFS of northwest corner rule gives what? 94 rupees. Now I taken the same problem. Now I am solving this one by LCM. LCM means, that indicates what? Least cost method. Least cost method, the first letter of each word, LCM. Now here I had told you very clearly, before going to solve this problem of TP, you have to check the condition is what? Balanced. It is very clear, we taken the same problem. So this is what? Demand equal to supply. So it is very clear, no need to check it again, because we taken the same one. No? Now least, we are going to select the least cost among this. Which is a least cost? What is that inside the table that indicates cost? Now you are selecting the least one among that. Which is the least here? Here the first one is 0. Here supply 7, 12, 11. Now see in that, which is the least among this? 0 is the least, whose demand is what? 10. Now you are going to see the factory also. The corresponding factory only you have to see. Now you select that cost is least one is 0, whose demand is 10, whose corresponding available level is what? 12. Your demand is 10, that's why you've taken the 10 from there, you keep the remaining 2 in the factory itself, in the godown itself. You've taken 10 units from the factory, you supply here. So you compare these two. Here the destination is over, or the factory level is over. So it indicates what? Destination is over. That's the reason the destination part you are going to remove the problem. Okay, with the remaining 6 cells only you are going to consider for the next case, next stage, next level to proceed this problem. See, compare the 6 datas, which is the least among this. Here 1 is the least one. See that after selecting this cell, first you are going to see the demand one, whose demand is what? 10. The corresponding availability level of the factory is what? 11. So you need 10. You've taken the 10 from the factory. You leave the 1, the factory itself. You supply the 10 units to this cell of 1. You supplied 1 to this. You supplied 10 units to this cell. After supplying, I told you have to compare always which one we have to remove, which part you have to remove from this problem. Either the destination we have to remove or the factory we have to remove. Here the destination 2, whose demand is entirely completed. That's the reason here destination 2 you are going to remove from the problem. The remaining you are going to proceed the next one. See here 6 to 5, which is the least among these 2. I told you very clearly, you after selecting this cell, first you are selecting the cell, then you come to the bottom of this. That's a demand, whose corresponding demand is at 10. Whose corresponding availability in the factory is what? 2. Here your demand is 10. That's the reason your demand is 10. But even though available level of factory is only 2, that's the reason you've taken only 2. You supplied only 2 in this place, but still the demand is there. You supplied only 2. The remaining will come what? 8. So here which is completely over, either factory level is over or destination level is over. Still the destination demand is there, but factory is fully over. Nothing is there in the factory. You remove the factory in this second row you are removing. Then remaining 2 cells only you are considering, 6 and 5. Now comparing these two, the least is what? 5. So now whose demand is what? 8. First I told you very clearly, you see the bottom of that is demand is 8, then corresponding available of the factory level is 1. You need 8, but only 1 is available in the factory. That's the reason you can supply only 1 in this. You supplied only 1, but still your demand is there. Demand is what? 7. Now you check that either factory is part is over or destination part is fully over. Here the factory is over. That's the reason you remove the again factory part F3 from the problem. It's the last only one cell is remaining. That is what? 6. You check the demand is what? 7. Whose corresponding available level is what? 7. If it is 7, available need is also 7, available level is also 7. You can supply here in the cell 7. Now this is also getting cancelled, this is also getting cancelled. So now the problem is ends. No demand is here and no supply is what? Everything is getting cancelled. That comes only when it is demand equal to supply. When it comes like this, that only you can say is a what? Feasible solution. Do remember the word feasible solution. When it comes feasible, if it is a demand equal to supply. Why I am repeating this same again and again? Because the last 2 or 3 times the same question is repeated. When the problem of TP will come feasible, demand equal to supply. So now after supplying like this, after supplying like this, you are going to find the solutions called IBFS. Initial basic feasible solution. Just you are going to supply in this what? 6 units into 7 plus 0 into 10, then plus 2 into 2, then 1 into 10, then 5 into 1. So here 6 into 7, 42. 0 into 10 becomes 0, 2 into 2, 4, 1 into 10, 10, then it is what? 5. It gives 62 and 52 plus 9, which gives the value is 6. Just to add the values, 42, then 46, 56, it is what? 61. If you are solving the same problem, you are supplying the same level of goods from the source place to the what? Destination. Here that a northwest corner rule by solving the same problem, which gives the what? You are going to spend minimum of 94 rupees. The same problem if you are going to solve by the LCM, you are going to spend what? 61 rupees. See the difference in this. So LCM and northwest. Now I am going to explain the another method. We have 3 methods: northwest corner rule, LCM, and Vogel's approximation method, or it is called what? Penalty method. The northwest corner, which gives in this problem what? IBFS value is 94, LCM which gives what? 61. Now we will solve the same problem by Vogel's approximation method. VAM method, Vogel's approximation method. Now I will take the same one because you will come to know the difference among the methods. Here 3 boxes, 3 rows, 3 columns, 1, 2, 6. We are solving by what? VAM. Why I am taking the same data means you will come, then only you can compare which is the best. You can decide among the 3. 3, 1, 5. Also demand is 10, 10, 10, and the supply is 7, 12, 11. Now the VAM is called Vogel's approximation method. Approximation method. The another name also you can call it as penalty method. Penalty method. Now before going to solve, you are going to check the balance condition. It is all very clear because we are taking the same problem. This problem is balanced. Okay, there the demand equal to supply, D equal to what? Supply. This problem is balanced. Now penalty. We are going to find the penalty. By using this penalty only you can solve this problem. Here first you are going to find that P1. This P1 represents that row wise penalty. Here this, if you are going to put the bottom, this P1 represents that column wise penalty. So first you should know what is penalty. Penalty is a difference between the first minimum and the next minimum. You are going to find the difference. So if you are going to select in this row, first row, what is the first minimum? 1. The second minimum is 2. You are going to find the difference between the second minus first. You are going to find the two minimum values. You may have many values, means you are selecting from that first two minimum values. The first minimum value is 1, the second minimum value is 2. Second minus first always. So suppose the 2 minus 1. Here that the P1, the row 1 penalty comes what? 1. Here come to the second row, the first minimum is 0, the second minimum is 2. 2 minus 0. 2. And similarly come to the third row, the first minimum is 1 and the second minimum is what? 3. 3 minus 1. Always second minus first. And this indicates what? Row wise penalty. Now we are going to find the column wise penalty. Here the first minimum is 0, the second minimum is 1. Second minus first, 1 minus 0, 1. Now first minimum is 1, second minimum is 2. Second minus first, 2 minus 1, 1. First minimum 2, second minimum is 5. 5 minus 2, 3. So now which indicates what? Minimum. Minimum of penalties. This is P1 penalty. We are going to compare the entire penalties. P1, entire penalty of what? P1. After finding the penalty, you have to see that the maximum among the penalty of P1. Both the P1 you are going to compare. Not only the column wise penalty or not only the row wise penalty. The P1 you can't compare the entire values of P1. So which is maximum among that? If you are going to select which is maximum here, 3. Now you can enter inside the problem through this path. The penalty which gives the path to enter inside the problem. So here penalty is a minimum difference first and the second, and you see the both the penalties, row wise penalty and column wise penalty. After finding this, you are going to compare entire values of the penalties of P1. So P1, if you are going to compare, 3 is a maximum. So through that you are going to enter inside the problem, that gives a path to you. So you are going to enter. After entering in this column 3, 3 comes corresponding to what? Column 3. After entering inside, you are selecting that in this column, which is minimum, in this column you are selecting the what? Minimum cost 2. So after selecting this 2, you see always what? Demand, whose demand is what? 10. Then corresponding factory availability is what? 12. Your need is only 10. That's why you have taken only from this factory. Keep the remaining 2 in the factory itself. You supply the 10 to this cell. Now after supplying this, you see whether factory is completely over or destination is completely over. You check both. Here factory is over. No, still the factory is having about 2. Here the destination's demand is fully completely over. 10 you supplied entire goods in this cell. So now you are going to remove the D3 from the problem. If you are going to put just cross line like this, you can proceed with the remaining cells only. So I am going to rewrite. You can rewrite the same one again and again. If you are going to rewrite the same, which takes more time, and sometimes you may commit some small mistakes while repeating the same data at the second stage. That's the reason just to put a cross line always. So you can complete the problem quickly. Now after crossing this, you are going to proceed with the 6 remaining cells. Now again you are going to find the penalties. Sir, how many penalties we have to find like this, sir? So now to find the penalty, the next one is what? P2. This P2 indicates row wise penalty. This P2 indicates column wise penalty. Here again that first minimum is 0, the second minimum is 1. Second minus first, 1. The first minimum is 2, the second minimum is 2. First minimum is 1, second minimum is 2. Second minus first, 1. Here this portion is removed from the problem. That's the reason just you are going to put a line. This is what? Removed. So now you are going to find that row wise penalty. Here this portion is removed. That's the reason you consider only the first minimum and the next minimum. 2 minus 1 is comes again the same one. First minimum, next minimum. 4 minus 0, 4. Now first minimum is 1, second minimum is 3. 3 minus 1, 2. Now again you are going to compare that entire P2. Entire P2 you are going to compare. Then only you can select the path to enter inside the problem, which gives the way to enter inside the problem. If you are going to compare that 1, 4, 2, 1, 1. So now which is maximum among this? 4 is the maximum. 4 comes corresponding to what? Row 2. Row 2. You can enter inside the problem through row 2. If you are going to enter inside this, now you can select the least one. If you are going to enter inside there, you have two cells, 0 and 4. Which is the least among this? 0 is the least. Now if selecting these cells, you are checking this whose corresponding minimum, corresponding destination demand whose 0, whose demand is 10, and you check the corresponding factory 2. You need 10. Even though the available level of the factory is 2, the reason only you can take the 2 units from the factory, but still your demand is there. Only the factory is completely over. So that's the reason you can remove the factory from the problem. You see, compare after substituting like this, after allocating the cells, you are checking that which one we have to remove. You blindly can't remove everything. Which part is completely over. Data is nothing is there in that to proceed next. So the factory is over. So remove the factory from this. So to proceed next, you have what? Only 1 and 2, 3 and 1. So again we are going for what? P3. Sir, how many penalty we have to find, sir? I'll tell you, wait. So now in this row, what is the penalty? First minimum, next minimum. 2 minus 1. 2 minus 1. So it's what? 1. This row is removed. The factory is removed from the problem. Just to put a dash in this. And here we have only 3 and 5. So 3 minus 1. 3 and 1. 5 is removed. This part is removed. The row is removed. That entire what destination value is removed. Just you are going to calculate with the two cells, 3 and 1. So first minimum 1, second minimum is 3. 3 minus 1, 2. This is what? Row wise penalty. This indicates row wise penalty. Now you come to the column wise penalty. Here P3, 1, 3. 3 minus 1, 2, and 2 minus 1, 1. Now we are going to consider the P3. Consider the P3. Now, sir, how to enter inside that? I have given the clue also. After comparing this entire one, which is a maximum among this, but you are having a 2 2s here. Here also coming 2, here also coming 2. So if it is equal or is, you can choose any one among that. So I am selecting this 2. So now after selecting, you can go, if you are going to select this 2, you can enter through row 3. If you are selecting this 2, you are going to enter what? The column 1. So through that way you are going to enter in this. Suppose I am selecting this one. I am going to enter inside that problem through what? First column. So I am entering in this way. I am choosing in this among the two cells 1 and 3, which is the least among these two values 1, whose demand is what? 8, whose corresponding availability of the factory. If you are selecting this destination, you are going to see the corresponding factory only. Here whose demand is 8, whose corresponding available level of factory is what? 7. That's the reason you can take only 7 from there. Still your destination demand is there. So you can supply only 7 units to the cell. After supplying, which one we have to remove from the problem? Again we will get it out. So which part is fully over? Either destination part fully completed or the factory level is completed. If the factory level is entirely completed. So that's the reason you are going to remove the factory from the problem. Now we have remaining 2 cells only to proceed further, 3 and 1. So if it is only 2 cells are there, whether it is possible to find the next penalty level or not. See, penalty which represent always what? Difference of 2 values. So here we have only 2 columns, but 2 rows are not there. When it comes 1 row or 1 column, you can stop the penalty. You don't need to proceed for the penalty cases. You can stop the what penalty part. You don't need to go for proceeding of what finding a penalty. One row or one column comes, stop that. You can go with the remaining without finding a penalty. See what is the cells are. What are the cells are there remaining? 3 and 1. So no need to find P4. Reason is only you have one row, but you have two columns but only one row. That's the reason one row or one column comes, stop that. With the remaining of 3 and 1, which is the least among this 1. What is the need of this cell? Destinations 10. So you check the corresponding factory. You need 10. Here available level of the factory is what? 11. So you've taken only 10 from there. You keep the remaining 1 in the factory itself. You supply the 10 to this place of 1. So now here the destination 2 whose demand is entirely completed. Now the remaining we have only one cell is what? 3. Now 3 whose demand is 1, whose corresponding available level in the factory is what? 1. So you can take the 1, supply the 1 in this. Now entire destinations demand is over and the factory available level is over. So nothing is remaining. Destination demand is nothing and what? Factory level is available is also nothing. So when it comes and like this, when the problem is demand equal to supply, if it is satisfying this condition, then only will get what? Feasible solution. After finishing like this, you are going to find that solution is called what? IBFS, initial basic feasible solution. IBFS. So one unit, this is the cost of the place 1. How much you supplied here? 7. So 1 into 7 plus 0 into 2 plus 2 into 10 plus 3 into 1 plus 1 into 10. Now you add all the values. 7, 0, 20, 3 and 10. Here 10, 30 and is what? 40. So you are going to spend the rupees of what? 40. I taken the same problem. I solved the same problem by using these 3 methods. So now here if you are going to compare that the 3 methods, here northwest corner rule, the value is what? 94 rupees. And that LCM least cost which gives what? 61. You are spending what? 61 rupees. 61, 94, 61. The same problem we solved by the method of VAM. The VAM value which comes what? 40 rupees. The same problem we solved by VAM which gives what? 40. See the value? 40, 61, 94. By comparing these 3 values, you see which is the best among this, which gives the appropriate value to that transportation problem, the minimized value. The VAM which gives the what? Always the minimized value. That's the reason VAM is always the best one among these 3. So you select always the VAM which gives the best solution in the transportation problem to find the IBFS, and sometimes the VAM solution also may be a what? Optimal solution to the transportation problem. And one more thing I want to explain to you. I told you very clearly that I will explain the 2 things after completing that IBFS. See here the transportation, the number of basic variables in an M cross N balanced transportation problem, at most M plus N minus 1. See M plus N minus 1 basic variable. I will explain the basic variable. Now I am going to explain the what? Basic variables. The rule is what? M plus N minus 1 to find the basic variable. What is M denotes? Number of rows. Here in this problem number of rows is what? R equal to 3, and the column is also what? 3. So therefore that 3 plus 3 minus 1, this gives what? 5. See here, basic variable, how many cells you allocated? 1, 2, 3, 4, 5. See that the basic variable of this given problem is 5. Number of cells allocated, you are getting this, what? 5 cells are allocated. Therefore the basic variable, this variable which gives the feasible solution to you. Through the basic variables only you are getting the feasible solution. The basic variable is nothing but the what? Number of allocated cells. That you are going to find the formula of m plus n minus 1 equal to number of m plus n minus 1, 3 plus 3 minus 1, that gives what? 5. 5 cells are allocated. So this is a basic variable. What is a non-basic variable? Non-basic variable. Non-basic variable. Non-basic variable of TP. This formula is m into n minus m plus n minus 1. This is the what? Formula for non-basic variable. See, I am taking the same example. For m into n, what is how many rows are there? How many rows? How many columns? 3 rows, 3 columns. So 3 into 3, 9, minus m plus n minus 1 value is what? 5. 9 minus 5 is what? 4. This gives the what? Non-basic variables. Non-basic variable means number of non-allocated cells. Number of non-allocated cells is 1, 2, 3, 4. 1, 2, 3, 4. The remaining non-allocated cells only you can say is a non-basic variable. The allocated cells you can say is a what? Basic variable. Here the basic variables are 5 because the 5 cells are allocated. The non-basic variable value is what? 4. Non-basic variable what? 4. 4 which gives the what? Non-allocated cells. Non-allocated cells 1, 2, 3, 4. So these 2 points are very important to write any competitive exams. Do remember, they may ask that number of rows, number of columns they may give. If it is given, through that you can find the basic variable, and through that the non-allocated cells you can find the what? Non-basic variable. Thank you friends. So we will meet in the next video for optimum solution cases.